Hello guys, welcome back to my channel Cubics Lifestyle. I'm Feba and today I'm here with another video based on solutions for CBSE Standard 12 Mathematics Chapter 3 Matrices, Exercise 3.3. First question, find the transpose of each of the following matrices. There are three sub-questions. Let's see the first question. It is phi 1 by 2 minus 1. That is the first question. We have to write the transpose. When we write the transpose, the given column would be written in the form of a row and given row would be written in the form of a column. So when we write this column into a row format, that is, the answer would be 5, 1 by 2 and minus 1. The second part of the question is 1, minus 1, 2, 3. It would be written as 1, 2, minus 1 and 3. The third part of the question is minus 1, 5, 6, root 3, 5, 6, 2, 3, minus 1. And the solution would be minus 1, root 3, 2, 5, 5, 3 and 6, 6 minus 1. So I hope you guys understood. Second question, if A is equal to minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1 and B is equal to minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1, then verify that first part would be A plus B the whole transpose is equal to A transpose plus B transpose, and second part is A minus B the whole transpose is equal to A transpose minus B transpose. First, let's solve the first part of the question. In order to solve the first part of the question, first write the given A matrix and write down its transpose, that is A transpose equal to minus 1, 5, minus 2, 2, 7, 3, 7, 1 and 3, 9, 1. Then write down the given B matrix, that is this, and write down its transpose, that is B transpose is equal to minus 4, 1, 1, 1, 2, 3, minus 5, 0, 1. Now, the first part of the question is A plus B the whole transpose is equal to A transpose plus B transpose. So, first consider A plus B. First consider the LHS part, that is A plus B the whole transpose. First consider A plus B, that is to add both A and B, which will give us an answer of minus 1 plus minus 4 is minus 5, 2 plus 1 would be 3, 3 plus minus 5 would be minus 2, 5 plus 1 would be 6, 7 plus 2 would be 9, 9 plus 0 equal to 9. Minus 2 plus 1 is minus 1, 1 plus 3 would be 4 and 1 plus 1 would be 2. So this is the sum of both the matrices. Now we have the A plus B matrix, so we will write A plus B the whole transpose, that is the transpose of this matrix, that would be this one, that is minus 5, 6, minus 1, 3, 9, 4, minus 2, 9, 2. So we have found A plus B the whole transpose. Next, we would find the RHS part, that is A transpose plus B transpose, that would be minus 1, 5, minus 2, 2, 7, 1, 3, 9, 1 plus minus 4, 1, 1, 1, 2, 3 and minus 5, 0, 1. That would minus 1 plus minus 4 would be minus 5, 5 plus 1 would be 6, minus 2 plus 1 would be minus 1, 2 plus 1 would be 3, 7 plus 2 would be 9, 1 plus 3 would be 4, plus minus 5 would be minus 2. 9 plus 0 would be 9, and 1 plus 1 would be 2. When we see it, this is the sum, that is minus 5 6 minus 1 3 9 4 minus 2 9 2. So we can verify that this is equal to, since this is equal to LHS, we can verify that A plus B the whole transpose is equal to A transpose plus B transpose. The second part of the question is A minus B the whole transpose is equal to A transpose minus B transpose. So, as we have done in the previous question, we would be doing first considering the LHS and take A minus B. We would subtract B matrix from the A matrix. We would get um, minus 1 minus of minus 4 would be 3. 2 minus 1 would be 1. 3 minus of minus 5 would be 8. 5 minus 1 would be 4. 7 minus 2 would be 5. 9 minus 0 is 9. Minus 2 minus 1 would be minus 3, and 1 minus 3 would be minus 2. 1 minus 1 is 0. And since we have got the A minus B matrix, we will find the transpose of that is A minus B the whole transpose would be 3 4 minus 3 1 5 minus 2 8 9 0. Now we have already got the value of LHS in the previous part. Now we would consider the RHS part, that is A minus B, the A transpose minus B transpose, that is equal to, first write the A transpose and matrix, and then subtract B transpose matrix from the A transpose matrix. We would get minus 4 minus 1 minus 4 would be 3. 5 minus 1 would be 4. Minus 2 minus 1 would be minus 3. Minus 3. 2 minus 1 would be 1. 7 minus 2 would be 5. 1 minus 3 would be minus 2. 3 minus 5 would be minus 2. 9 minus 0 is 9. And 1 minus 1 would be 0. So we have found this is the value of A transpose minus B transpose. When we consider this to the value we got in LHS, we would see that it is equal. So we have found that LHS is equal to RHS, hence this is verified. Third question is, if A transpose is the given matrix and B transpose is this given matrix, then verify that first part A plus B the whole transpose is equal to A transpose plus B transpose, and second part A minus B the whole transpose is equal to A transpose minus B transpose. So first we will write the both given equation matrices, that is matrix of A transpose and B transpose. You have to focus on this part. This is A transpose and this is B. So in order to find A, we would consider transpose of A transpose. That would give us the value of A, that is equal to 3 minus 1 0 4 2 1. And we will write down the given B transpose from the B matrix, that is minus 1 1 2 2 1 3. Now the first part of the question we are going to solve it. That is A plus B the whole transpose is equal to A transpose plus B transpose. So first consider the LHS and take A plus B. We would add both. We would get 3 plus minus 1 would be 2. Minus 1 plus 2 would be 1. 0 plus 1 would be 1. 4 plus 1 would be 5, 2 plus 2 would be 4, 1 plus 3 would be 4. So now we have the A plus B matrix, that is this. Now as per the question, LHS is equal to A plus B the whole transpose. So we will find the transpose of A plus B, that would be 2, 5, 1, 4, 1, 4. Now we have the A plus B the whole transpose is equal to this. So we would consider the RHS, that is A transpose plus B transpose would be A transpose equal to 3, 4, minus 1, 2, 0, 1 plus minus 1, 1, 2, 2, 1, 3. Now we would add both, that would be 3 plus minus 1 would be 2. 4 plus 1 would be 5, minus 1 plus 2 would be 1, 2 plus 2 would be 4, 1, 0 plus 1 would be 1, and 1 plus 3 would be 4. So when we consider these both, the answer is equal. So LHS is equal to RHS. Hence it's verified that A plus B the whole transpose is equal to A transpose plus B transpose. Next, second part of the question is A minus B the whole transpose is equal to A transpose minus B transpose. So similarly, in the first part we did this question. In the previous question we did the same similar case. So do the same here. First consider LHS, and which is equal to A minus B the whole transpose. First, in order to find that, we have to find A minus B. That would be 3 minus 1 0 4 2 1 minus 1 2 1 1 2 3. That would be 3 minus 1 would be 4, minus 1 minus 2 would be minus 3, 0 minus 1 would be minus 1, 4 minus 1 would be um, uh, 3, and 2 minus 2 would be 0, 1 minus 3 would be minus 2. So this is the A minus B matrix. So we will take the A minus B the whole transpose now. That would be 4, 3, minus 3, 0, minus 1, minus 2. Now since we have found the LHS value, now we would consider RHS part, that is A transpose minus B transpose, which is equal to, this is A transpose. We would subtract the B transpose from A transpose, that is 3 minus of minus 1 would be 4. 4 minus 1 would be 3. Minus 3 minus 2 would be minus 3. 2 minus 2 would be 0. 0 minus 1 would be minus 1. 1 minus 2 would be 1 minus 3 would be minus 2. So this is the given, this is the answer we got after subtracting the B A transpose from A transpose. When we consider LHS and RHS, they are equal. Hence, it is verified that A minus B the whole transpose is equal to A transpose minus B transpose. Fourth question. If A transpose is equal to this given matrix and B transpose is equal to this given matrix, then find A plus 2B the whole matrix. So in order to find A plus 2B the whole matrix, we have to first find A transpose, that is A, which is the A is equal to A transpose of A transpose, that would be transpose of this matrix, that is A is equal to minus 2 3 no minus 2 1 3 2, that would be A, and plus 2 into B, that is minus 1 0 1 2. So we would add minus 2 plus minus 2, which would minus 4, 1 plus 0 1, 3 plus 2 5, 2 plus 4 would be 6. So transpose of A plus 2B would be minus 4 5 1 6. So this is the answer for A plus 2B the whole transpose. Hence we have found the answer. The fifth question. For the matrix A and B, verify that AB, the whole transpose, is equal to B transpose A transpose, where first part A is equal to this matrix and B is equal to this matrix. Second part would be A is equal to this matrix and B is equal to this matrix. So we have to first question would be this one, that is A is equal to 1 minus 4 3 and B is equal to minus 1 2 1. So let's consider the LHS part, that is AB, AB the whole transpose. So first consider AB is equal to 1 minus 4 3 into minus 1 2 1. Now we would multiply with each other. It would be minus 1 minus 1 2 1, and minus 4 into minus 1 would be 4, minus 1 into 2 would be minus 8, minus 4 into 1 would be minus 4. 3 into minus 1 would be minus 3. 3 into 2 would be 6. 3 into 1 would be 3. So this is the matrix AB. Now we have to find the transpose of AB, which would be minus 1, 4, minus 3, 2, minus 8, 6, 1, minus 4, 3. So this is AB, the whole transpose. We have written the LHS part. Now we will find the RHS part. So as per the question, we have found AB. Now this is the RHS part, which is equal to B transpose into A transpose. That would be minus 1 2 1 and 1 minus 4 3. Now minus 1 into 1 would be minus 1, minus 1 into 4 would be minus 4, no 4, minus 1 into 3 would be minus 3, 2 into 1 would be 1, 2 into minus 4 would be minus 8, 2 into 3 would be 6, 1 into 1, 1, 1 into minus 4, minus 4, 1 into 3 would be 3. So this is the matrix B transpose A transpose. So when we consider LHS and RHS, they both are equal. So LHS is equal to RHS. Hence, it is verified that AB the whole transpose is equal to B transpose into A transpose. Now, second part of the question is A is equal to 0, 1, 2 and B is equal to 1, 5, 7. Now, in order to find the solution, we would in order to verify the given condition, we would consider LHS part, that is AB the whole transpose. First, consider AB is equal to 102 into 157, which is equal to 0 into 1 0, 0 into 5 0, 0 into 7 0, 1 into 1 1, 1 into 5 5, 1 into 7 7, 2 into 1 2, 2 into 5 10, 2 into 7 14. So this would be the matrix AB. Now we will find the AB the whole transpose. So the transpose of this matrix, that would be 0 1 2 0 5 10 0 7 14. So we have found the LHS. Now consider the RHS part, that is this B transpose A transpose, that is 157 into 0 1 2. Now 1 into 0 0, 1 into 1 1, 1 into 2 2, 5 into 0 0, 5 into 1 5, 5 into 2 10, 7 into 0 0, 7 into 1 7, 7 into 2 would be 14. So this is the RHS bar, that is the matrix of B transpose A transpose. When we consider these both RHS and LHS, that they are equal, hence it is proved verified that the AB the whole transpose is equal to B transpose A transpose. Now sixth question from the exercise, that is, if first part A is equal to cos alpha sin alpha minus sin alpha cos alpha, Then verify that A transpose A is equal to I. We know that I is the identity. Identity would be 1 0 0 1. So we have to verify the first part would be A transpose A is equal to the identity matrix. Next one, second part of the question would be if A is equal to sine alpha cos alpha minus cos alpha sine alpha, then verify that A transpose A is equal to the identity matrix. So now we will consider now we will find the solution for the first part of the question, that is this question we would find the answer. So as for finding the solution, no, for verifying this condition, we will first write down the given matrix A, that is cos alpha sin alpha minus sin alpha cos alpha, and write down its transpose, that would be cos alpha minus sin alpha cos alpha. So we have to verify A transpose A is equal to identity matrix. So we would consider the LHS bar, that would be A transpose A, which is equal to cos alpha minus sin alpha cos alpha into cos alpha sin alpha minus sin alpha cos alpha. So we are multiplying both, which will give us cos square alpha plus sin square alpha minus cos alpha sin alpha plus sin alpha cos alpha minus sin alpha cos alpha plus cos alpha sin alpha sin square alpha plus cos square alpha. Cos square alpha plus sin square alpha would be similar to sin square theta plus cos square theta, which would be equal to 1. So the answer would be 1 minus sin alpha cos alpha and sin alpha cos alpha were um, go cancel out, which would leave us 0, and minus sin alpha cos alpha plus cos alpha sin alpha would also cancel out, leaving us 0, and sin square alpha plus cos square alpha would be equal to 1. So this would be the matrix, that is the solution. When we consider this to the identity matrix, both of them are equal, so it is equal to I. Therefore we have verified that A transpose into A, which is equal to I, hence it is verified. Now moving on to the second part of the question, it is if A is equal to sin alpha cos alpha minus cos alpha sin alpha, then verify that A transpose A is equal to I. So let's first write down the given matrix A, that is sin alpha cos alpha minus cos alpha sin alpha, and write down its transpose, that will be sin alpha minus cos alpha sin alpha. Now we will multiply both these matrices, that is A transpose into A is equal to sin alpha cos alpha, no, sin alpha minus cos alpha sin alpha into sin alpha cos alpha minus cos alpha sin alpha, which will leave us with sin square alpha plus cos square alpha, um, that and uh, sin minus sin alpha cos alpha plus cos alpha sin alpha, and and next one will be minus cos alpha sin alpha sin alpha plus sin alpha cos alpha, and cos cos square alpha plus sin square alpha, which will be equal to 1001, which is equal to I. Hence it is verified that A transpose A into A is equal to identity matrix. Seventh question, first part. Show that the matrix A is equal to 1 minus 1 5 minus 1 2 1 5 1 3 is a symmetric matrix. Second part, show that matrix A 0 1 minus 1 minus 1 0 1 1 minus 1 0 is a skew symmetric matrix. Before I explain the solution, let me say that the condition for a symmetric matrix is that the transpose of the particular matrix should be equal to the matrix. So A should be equal to A transpose. Then it would be a symmetry. And if for skew symmetric matrix would be the A transpose of the matrix should be equal to negative of that matrix. That would be A transpose is equal to minus A. So these are the two conditions for conditions for symmetric and skew symmetric matrices. Now let's move on to the solution. First part of the first part of the question is this one, that is A is equal to 1 minus 1 5 minus 1 2 1 5 1 3 is a symmetric matrix. So first write down the given matrix as per the question and write down the transpose of that particular matrix. That would be 1 minus 1 5 minus 1 2 1 5 1 3. Now compare the transpose of that matrix and the matrix with each other. You would find that it is equal. So A is equal to A transpose. That proves the condition for the matrix to be symmetric. Hence it is a symmetric matrix. Now the second part of the question is to show A which is equal to 0, 1, minus 1, minus 1, 0, 1, 1, minus 1, 0 is a skew symmetric matrix. Now write down the given A matrix. Now consider the transpose of it. That would be 0, minus 1, 1, 1, 0, minus 1, minus 1, 1, 0. Now when you compare it, the A transpose is the particularly negative of this A. So we can write that A transpose is equal to minus A, or A is equal to minus A transpose. So it is proved that it is a symmetric, skew symmetric matrix. Eighth question, for a matrix A which is equal to 1 5 6 7, verify that first part A plus A transpose is a symmetric matrix. Second part, A minus A transpose is a skew symmetric matrix. Okay, let's for the solution, right solution. First part of the question. First, write down the A matrix and A transpose matrix. Then consider A plus A transpose is equal to B. So now B is equal to add A matrix along with A transpose. It would give us 1 plus 1 would be 2, 5 plus 6 would be 11, 6 plus 5 would be 11, 7 plus 7 would be 14. So A plus A transpose is 2, 11, 11, 14, which is equal to B. Now we will find out B transpose, which would be equal to A plus A transpose, the whole transpose, which would be also equal to A plus A transpose, which is equal to 2, 11, 11B. So since it is equal to A plus A transpose, it is equal to B. So we will get that B is equal to B transpose. That therefore B is equal to A plus A transpose is a symmetric matrix. Second part of the question is A minus A transpose is a skew symmetric matrix. So solution would be, first write down the A matrix and its A transpose. Consider B is equal to A minus A transpose. which is equal to 1567 minus 1657, which would give us 0 minus 1 1 0. Now consider B transpose is equal to A minus A transpose the whole transpose, which is equal to A transpose minus A, which would give us 1657 minus 1567, which is equal to 0 1 minus 1 0, which is equal to minus of B. Since B transpose is equal to minus B, B equal to A minus A transpose is a skew symmetric matrix. Ninth question. Find half of A plus A transpose and half of A minus A transpose when A is equal to 0 A B minus A 0 C minus B minus C 0. So as per the question, write down the A matrix in the solution. Then write its transpose, that is A transpose equal to 0 minus A minus B, A 0 minus C, B C 0. Now first find A plus A transpose, which would be equal to 0 A B A minus C 0 C minus B minus C 0 plus 0 minus A minus B A 0 minus C B C 0 is equal to 0 minus C 0 plus 0 0. A minus A is equal to 0. B minus B equal to 0, A minus A equal to 0, 0 plus 0 would be 0, C minus C would be 0, minus B plus B would be 0, minus C plus C would be 0, and 0 plus 0 also would be 0. So all the contents in this answer of A plus A transpose matrix would be 0. So next find out A minus A transpose, which would be equal to 0 B minus A 0 C minus B minus C 0 minus 0 minus A minus B A 0 minus C B C 0 is equal to 0 plus 0 minus 0 would be 0. A minus of minus A would be 2A. B minus of minus B would be 2B. Minus A would be minus 2A. 0 minus 0 would be 0. Z minus of minus C would be 2C. Minus B would be minus 2B. Minus C would be minus 2C. And 0 minus 0 would be 0. Now let P be half of A plus A transpose and Q be 1 by half of A minus A transpose. Now consider P is equal to half of A plus A transpose, which is equal to 1 by half 2 of the matrix containing zeros, which would also give us the matrix 0 0 0 0 0 0 0. Hence, so when we consider P transpose, it would be also the same. So we can write that P transpose is equal to P. So it is a symmetric matrix. Now consider Q is equal to half of A minus A transpose. It would be equal to half of 0 2A 2B minus 2A 0 2C minus 2B minus 2C 0 is equal to 0 A B minus C 0 C minus B minus C 0. So that is the value of Q. When we consider Q transpose, it would be written as 0 minus A minus B A 0 minus C B C 0. When we compare between Q and Q transpose, we can see that Q transpose is equal to minus of Q. Since Q transpose is equal to minus Q, we can write that Q is equal to half of A minus A transpose is a skew symmetric matrix. Now 10th question. Express the following matrix as the sum of a symmetric and a skew symmetric matrix. These are the sub question, that is first one would be 3, 5, 1, minus 1. Second one is 6, minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. And third one is 3, 3, minus 1, minus 2, 1, minus 4, minus 5, 2, and fourth one would be 1, 5, minus 1, 2. Now solution for the first part of the question. A is equal to, first write down the A matrix equal to A is equal to 3, 5, 1, minus 1. Now write down the transpose of A, that would be 3, 1, 5, minus 1. Now consider P is equal to 1/2 of A plus A transpose, which is equal to half of 3, 5, 1, minus 1 plus 3, 1, 5, minus 1, which would give us half of 6, 6, 6, minus 2. Now it would be equal to 6 by 2 would be 3, 6 by 2 would be 3, and 6 by 2 would be 3, and minus 2 by 2 would be minus 1. So this is the matrix P. Now consider the P transpose. It will be equal to 3, 3, 3, minus 1, which is also equal to P. So we can write that P is equal to half of A plus A transpose is a symmetric matrix. And now consider the Q is equal to half of A minus A transpose is equal to half of 3, 5, 1, minus 1, minus 3, 1, 5, minus 1, which is equal to half of 0, 4, minus 4, 0, which is equal to 0, 2, minus 2, 0. Now find the Q transpose, which is equal to 0, minus 2, 2, 0. When compare with Q, when we compare Q transpose with Q, we will see that Q transpose is equal to minus of Q, which would give us the which would prove that Q is equal to half of A minus A transpose is a Q symmetric matrix. Now we would add P and Q together, which would be equal to 3, 3, 3, minus 1 plus 0, 2, minus 2, 0, which would be equal to 3, 5, 1, minus 1, which is A. That is the question which we have asked. So we have represented this matrix as the sum of a symmetric and skew symmetric matrices. In the second part of the question, A is equal to 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3. Now write down the A transpose of the matrix, that would be 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3. Now let's consider P is equal to half of A plus A transpose, and Q is equal to half of A minus A transpose. Now let's consider P is equal to half of plus A transpose. For the So P is equal to half of 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3 plus 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3, which would give us P is equal to half of 12 minus 4, 4 minus 4, 6 minus 2, 4 minus 2, 6, which when we take half of each element, we would get 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3. When we take its P's transpose, it would be also equal to P. So we can write that P is equal to half of A plus A transpose is a symmetric matrix. Now let's consider Q is equal to half of A minus A transpose. Q is equal to half of 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3 minus 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3 is equal to half of 0, 0, 0, 0, 0, 0, 0, 0, 0 is equal to 0, 0, 0, 0, 0, 0, 0, 0, 0. We can now, when we say take Q transpose, it would be also equal to 0, 0, 0, 0, 0, 0, 0, 0, 0. We can consider that Q, when we do Q minus of Q would also be this. So, we can write that Q transpose is equal to minus Q. Therefore, Q is equal to half of A minus A transpose is a skew symmetric matrix. Now we will add P and Q together, which would be 6 minus 2, 2 minus 2, 3 minus 1, 2, 2 minus 1, 3 plus 0, 0, 0, 0, 0, 0, 0, 0, 0, which would give us 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3 is equal to A. So we have represented it as the sum of a symmetric and its skew symmetric matrices. The third part of the question is A is equal to 3, 3 minus 1 minus 2 minus 2 1 minus 4 minus 5 2 and now find out A transpose and write it down here. That is 3 minus 2 minus 4 3 minus 2 minus 5 minus 1 1 2. Now, first find out A plus A transpose is equal to 3, 3 minus 1 minus 2 minus 2, 1 minus 4 minus 5, 2 plus 3 minus 2 minus 4, 3 minus 2 minus 5 minus 1, 1, 2. When we add both, we would get 3 plus 3 6, 3 plus minus 2 would be 1, minus 1 plus minus 4 would be minus 5. Minus 2 plus 3 would be 1, minus 2 plus minus 2 would be minus 4, 1 plus minus 5 would be minus 4, minus 4 plus minus 1 would be minus 5, minus 5 plus 1 would be minus 4, 2 plus 2 would be 4. That is, this is the product sum of A plus A transpose, and now we would find A minus A transpose, which is equal to 3, 3 minus 1 minus 2 minus 2 1 minus 4 5 2 minus 3 minus 2 minus 4 3 minus 2 minus 5 minus 1 1 2. 3 minus 3 would be 0, 3 minus of minus 2 would be 5, 3 1 minus of minus 4 would be 3, minus 2 minus 3 would be minus 5, minus 2 minus of minus 2 would be 0, 1 minus of minus 5 would be 6, minus 4 minus of 1 would be minus 3, minus 5 minus 1 would be minus 6. And 2 minus 2 would be 0. So this is the matrix A minus A transpose. Now let P is equal to half of A plus A transpose and Q be half of A minus A transpose. Now consider P is equal to half of A plus A transpose is equal to half of 6, 1 minus 5, 1 minus 4 minus 4 minus 5 minus 4, 4 is equal to 3, 1 by 2 minus 5 by 2, 1 by 2 minus 2 minus 2 minus 5 by 2 minus 2, 2. Now write down P transpose is equal to 3, 1 by 2 minus 5 by 2, 1 by 2 minus 2 minus 2 minus 5 by 2 minus 2 2. When we consider P and P transpose, it is equal. So we can write that P is equal to half of A plus A transpose is a symmetric matrix. Now consider Q is equal to half of A minus A transpose is equal to half of 0, 5, 3 minus 5, 0, 6 minus 3 minus 6, 0 is equal to 0, 5 by 2, 3 by 2 minus 5 by 2, 0, 3 minus 3 by 2 minus 3, 0. Now find out the Q transpose, which should be also equal to 0 minus 5 by 2 minus 3 by 2, 5 by 2, 0 minus 3, 3 by 2, 3, 0. When we consider Q transpose and Q, we can find out that Q transpose is equal to minus of Q, which by which we can write that Q is equal to half of A minus A transpose is a skew symmetric matrix. Now add P and Q together, we would get 3, 1 by 2 minus 5 by 2, 1 by 2 minus 2 minus 2 minus 5 by 2 minus 2, 2 plus 0, 5 by 2, 3 by 2 minus 5 by 2, 0, 3 minus 3 by 2 minus 3, 0. 3 plus 0 would be 3, 1 by 2 plus 5 by 2 would be 6 by 2, which is equal to 3. Minus 5 by 2 plus 3 by 2 would be minus 2 by 2, which is equal to minus 1. 1 by 2 plus minus 5 by 2 would be minus 4 by 2, which is equal to minus 2. Minus 2 plus 0 would be minus 2. Minus 2 plus 3 would be 1. Minus 5 by 2 plus minus 3 by 2 would be minus 8 by 2, which is equal to minus 4. Minus 2 plus minus 3 would be minus 5. 2 plus 0 would be 2. Now we have got the sum of P and Q, which is equal to A. So we can write that it is represented as the sum of asymmetric and skew symmetric matrices. Now fourth part of the question is equal to 1, 5 minus 1, 2. Now write A transpose is equal to 1 minus 1, 5, 2. And let P is equal to half of A plus A transpose and QP half of A minus A transpose. First find out A plus A transpose is equal to 1, 5 minus 1, 2 plus 1 minus 1, 5, 2. 1 plus 1, 2, 5 minus 1, 4, minus 1 plus 5, 4, 2 plus 2, 4. A minus A transpose now is equal to 1, 5 minus 1, 2 minus 1 minus 1, 5, 2. 1 minus 1, 0. 5 minus of minus 1 would be 6. Minus 1 minus 5 would be minus 6. 2 minus 2 would be 0. So this is A minus A transpose. Now consider P is equal to half of A plus A transpose is equal to half of 2, 4, 4, 4 is equal to 1, 2, 2, 2. Now let's consider P transpose. It would also be 1, 2, 2, 2. So P and P transpose are equal. So we can write P is equal to half of A plus A transpose is a symmetric matrix. Now consider Q is equal to half of A minus A transpose is equal to half of 0, 6 minus 6, 0 is equal to 0, 3 minus 3, 0. Now consider Q transpose is equal to 0 minus 3, 3, 0, which would be when we consider Q transpose and Q, we can find that Q transpose is equal to minus of Q. So we can write Q is equal to half of A minus A transpose is a skew symmetric matrix. Now add P and Q together, that is 1, 2, 2, 2 plus 0, 3 minus 3, 0, which is equal to 1 plus 0, 1, 2 plus 3, 5, 2 plus minus 3 minus 1, 2 plus 0 equal to 2, which is equal to A. Since therefore it is represented as the sum of symmetric and skew symmetric matrices. So we have finished that question. This was the last question in the 10th question. Now choose the correct answer in the exercise 11 and 12. 11th question. If A, B are symmetric matrices of same order, then AB minus BA is the first one skew symmetric matrix, second one symmetric matrix, third one would be zero matrix, and fourth one would be identity matrix. The answer is skew symmetric matrix. 12th question. If A is equal to cos alpha minus sin alpha cos alpha, then A plus A transpose is identity matrix if the value of alpha is. So the options are pi by 6, B pi by 3, C pi, D would be 3 pi by 2. Answer would be pi by 3 because the solution is like this. Now we would first write down the A matrix and A transpose matrix. A transpose matrix would be cos alpha sin alpha minus sin alpha cos alpha. Now add both. Cos alpha plus cos alpha will be it is given that the sum of these would give us the identity matrix, that is 1 0 0 1. Now consider 2 cos alpha is equal to 1, then cos alpha would be equal to 1 by 2. We know that cos 60 is equal to 1 by 2. Therefore, the value of alpha is equal to 60. So we can write that pi by 3 is the answer because pi is considered to be 180 degree. 180 by 3 would give us 60. So the answer would be pi by 3. Hey guys, I hope you guys liked this video and understood what I have said in the video. If you like the video, please like, share, comment. And for further updates, subscribe to my channel. Bye.